Hi, I'm Gabriel. I want to show you something really nice I made with AKCP team this summer. It's a computational fluid dynamic module for the AKCP Pro server. If you know what CFD, computational fluid dynamic, is, you're probably scared. You think about meshing, drawing, boundary condition, Navier-Stokes equation. So yeah, no, that's not complex like that. We made a small, we made something really nice. It's a CFD server, so you can install it on your computer, and then you just connect it with their software by activating it in the menu here. CFD simulation. You put your information and everything. Don't try this server; it won't work. It will be deactivated. But yes, I want to show you how easy it is. So we'll go in map. We will add a new data center that we call the new server room, the server room. Then we will create the empty. Rack is because they make a sensor for data center, so they follow each blade in a rack. Uh, we won't use it. We will just look globally of how things are moving. So that is the drawing software they made. It's really good. Uh, you can we will unlock it and go in an editor mode. So what we will do is they call it hot containment. So we will put the rack in a row and put the behind in a containment that will contain the heat, the hot air, and we will send it in the ceiling to go in air conditioning unit. Then the air conditioning unit will exit cold air, and the server will take the cold air from the global room. You will see a bit more when we will draw it. Uh, so that's the drawing software, like I told. We will configure the floor. So we said the height will be 2.7 meter. Okay, like I told, we will push the air in a false ceiling. So we need a gap, but we need a ceiling a bit lower than the height of the room. So 2.3, and our rack are 1.7 meter high. We can configure also for false floor for cold containing unit, but that's another subject. So now everything is configured. So we can put the rack with the rack icon right there. We can change the parameter of the rack. Since we set the height in the menu, the height is set there, but we can change it if it's different for each rack. But usually data center are really standard is Z. Sorry for this. The standard is Z. Anyway, so usually they use the same rack everywhere. So that's our rack. That's our front. That's our back. We will make a two row of four rack. Yeah, the drawing software have all tool you can imagine. Snap to object. That will be really useful. Here we go. And 2, 3, 4. Make a copy. 4. Okay. Selecting for multiple object. Make a copy. Great. We will flip it. Great. And then we will put containment. So the containment represent the wall, the door, and everything to contain the air. So we will just put it right there between the two. We will fiddle a bit. So click Control and select them, and go with the arrow to just control. Yes, I'm a bit. Here you go. Okay. So we have a containment, we have our rack. The back of the rack is in the containment. We can make it a bit larger to be sure it's inside, like that. Okay, so now we will need the vent. You got many layers, so you can go on ceiling. You have those vent. Those vent are only on the ceiling. So we have vent on the floor. Like I say, we can do cold containment also with the cold air that we want to send on the floor because cold air goes down. But with what we want is vent with conduct. So it's the center layer. So we select vent, it's that icon, and we will put it on our containment like that. Make a copy. Here you go. So their customer usually already have those maps. They have their data center with all the information, and the drawing is already made. So that step is already done usually. Okay, so now we will put a crack. So we want the crack is a cooling unit. So they have many different crack, different configuration that take from the ceiling, or from the room itself. So we want the top front. That's that one. Here we go. Make a copy. Let's rotate it like that. So we have our computer room. We will make it a bit smaller. Like that. Okay, good. We'll make the put a room. I was sure I put 6 for the room with the maybe I didn't save 6 6. Okay, go. Great, 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 great. Just put that a bit higher, like that. So like you see, the drawing tool is really good. They work really hard for it. They correct a lot of bug. Yeah. So we have our out containment server room. It's already done. In fact, we are. If we can see in 3D. So yes. So we have our rack or a cooling unit, or duct to go that goes in the ceiling, and everything looks good. We can even put to door. Containment already represents the door, but if you like, you can just put them like that. Here you go. Pretty nice, huh? So only step that's left is to start this the simulation, really. So the small GUI appears and it asks you if everything is like you put it. Okay, then you get the second step. AKCP usually provide two layers of 3 probe that get the heat, and another probe that get the power usage of your rack. So usually the customer can click on a load value from the sensor, and they take the sensor that already exists. They fill the form with what's happening right now. But since we don't have any data center, we will fill it by default. So our containment is perfect. We don't leak any air. So what's get out. Great, perfect. Okay, so we have the power value. So here again, we can load from the sensor, but we don't have a data center. So we have a rack have a 42 unit of 120 watts. So it's about 5040. And since we have uh, 8 rack like that, and we have 2 cooling units, we need about 20,000 watt of cooling. Okay, seems good. Okay, since we know the temperature of the air getting out of the rack, and the crack. And we also know the power usage from the rack and the crack. We can compute how much air pass to keep that temperature. So you don't need any air velocity probe. They are really expensive. You don't want to use them. So you don't need it. We have enough information to get the airflow. We finished. And the last step, if I want to start the CFD simulation, oh yes, yes, okay. So the simulation is starting, and it will take. It's depend of the server you put CFD server on. For a small room like that, it can take 2 or 3 hours. So you can do any other thing. Everything is automatized. The software will do the meshing, will do the drawing. The drawing, the meshing. It will set your boundary condition. It will set the discretization. Everything is done for you. It, really, it's finished. You made it. You made maybe a week worth of work in 5 minutes. So it's really impressive. So I will come back with the results in a few seconds. Yeah, so it took 1 hour for that small model to finish. And yeah, let's see what it does. So first thing you have to do is to be sure that the lock is black, so you don't move anything you don't want to move. First thing that we can see is that I forgot to put the container vent on the crack, so our air is not guided in the cooling air cooling unit. So right now we have the air velocity and the direction of the air moving around. So we have a mapping right there with the strength here. So I moved it so it's not cut right. Yes, we zoom a bit up. We put back the arrows. So yeah. Like I told, I forgot to put the here the containment around the inlet of the crack. So here is going a bit everywhere. But we see that for the containment here, everything is like we plan. So the air gets in, goes in the ceiling, and goes down. We can look at the temperature also. But temperature doesn't change much, because yeah, we said it's perfect. I will have a mistake on the inlet here because of my mistake. So yeah, the model is always as precise as you are. So we have hot air that's going to get out, getting here and get down here. But since our air is cold, our model have a difficulty to solve that boundary condition, so we can see that it does something wrong. So if you do mistake like I did, your result would be a bit different than the reality. So yes, we have all the directions, so we can see on X. We can put back the server. I don't know how I remove them. Yeah, X, Z. Yeah, airflow on Z. Here we go. We remove on X. Right there. So that's our rack. That's yeah. We can do all the direction. We can even do the vents. Only the vents. Right there, like that. It's important because you can have backflow or a problem like the problem I just created by doing the mistake. So we see that the air is not going straight, it's going a bit everywhere. So yeah, you have the tool, all the tool you can imagine. You even have a tool to follow the temperature. For example, the variation of the temperature. So for example, you did a mistake in your design. You can quite easily detect it with that feature. So we will see the mistake I made. Okay, so like I told, I didn't put the conduct here. So what's happening is that the hot air and the cool air are mixing, and I can see it directly with the or temperature variation. So we can see that we have a high variation between the to temperature. So I can already see that I did a mistake. If it's not a design mistake like I did, and yeah, it's in reality, so maybe you have a gap under your rack and you drown it, so you can see that that you have mixing in your air. So yes, you have all the tool. Obviously, the model is as precise as you draw it. If you have the probe installed and you do a mistake in your drawing, you will have some inconsistency. So you can detect already that something is not like you would expect. I think my mistake does a really nice example right there with my boundary condition that is not good because the air is way cooler than supposed to be when it enter the crack, so my model fails. Like I told you, we can see it. We can see that I did a mistake. That's really good. I did a mistake because we can see how to detect it. Yeah, so I hope you try the software. It's pretty nice, in fact, yeah, and really quick. A CFD engineer can take weeks to do a model, and if he does a mistake like I just did, it's a week of work, a mistake, and you have to start again. So yes, I can correct my mistake in 2 seconds, like that. And yeah, like that. I just put that. Whoops! I just put those over my crack like that. I will just unlock it. Yep, map editor. We will snap to object and poop, poop. Et voila. Yes. Make a copy and put it there. Oops. Containment there. Take back here like that. So mistake is, oh, mistakes is fixed. It's so cool. It's so nice. I'm sorry. I'm so happy about that program. So goodbye, and I hope that you will try it.